We are now going to move on to the next conic section, which is hyperbolas. The first thing we're always going to do is write down the definition. Definition of hyperbola is the set of all points where? In a plane. The set of all points in a plane, okay, comma. That for each point on the hyperbola, each point on the hyperbola, comma, the difference between the distances to two fixed points. And what are we going to call those fixed points? We're going to call them foci, is constant. So I guess if you're going to be taking a test or looking for a key word here, we've got the difference between the distances, whereas ellipse was the sum. Okay, so if I take a look here, here's a hyperbola. I've got a focus point and a focus point. So if I take a look at the distance to this focus point, I'll call that D1. And then I'll take a look at the distance to this focus point, I'll call that D2. And all of the D1s minus the D2 is the difference is constant. So I don't know if it's constantly going to be 10 or not, but it's the same. Okay. The transverse axis is the one that has all the good stuff. So the transverse axis has the foci on it, has the center on it, okay, and has the vertices. On it. So if you take a look at this hyperbola here, this one here, I'm going to put T for transverse, has the two foci, has the two vertices, and has the center. So all the good stuff is on the transverse. And then the other one is called the conjugate. The conjugate one is going the other way, the other direction. So in this case, it would be going here. And all it has is it passes through the center. But the center is not actually a point on the hyperbola. Okay, so there's two ways you could draw hyperbolas. If the hyperbola is along the x-axis, then we've got a transverse. I'm going to put here the transverse is x. Okay, so then you've got a point right here on the rectangle, and the hyperbola is going to follow these asymptotes. It's going to be going left and right. And then if you have, okay, so a hyperbola along the x-axis would have a transverse of x. If the hyperbola is going along the y-axis, then that's his transverse. So that means the hyperbola is going up and down. So put a point on the edge of this rectangle, follow these asymptotes. Those asymptotes help you draw either a very skinny hyperbola or a very wide and fat hyperbola. Okay, so hyperbolas can be going left and right or up and down, depending on the transverse. Okay, let's see. We also have some foci points. Okay, so here's a focus point. I'll put a little F, little focus point here. Those are inside of the shape. Here's a focus point. Here's a focus point. And so there's some information we're going to learn about hyperbolas. In standard form, okay, let's just take a look at this one over here. If it's going left and right on the x-axis, then x is going to go first. X squared over r sub x squared minus y squared over r sub y squared, and that equals 1. So if you have an x transverse, then you put x first. Remember, hyperbola is the only shape that has the minus sign. If it's got a plus, then it's going to be an ellipse. If you're going up and down, then you're going to start with y squared over r sub y squared. So y's still go with y's, minus x squared over r sub x squared equals to 1. Okay, so that's the standard form depending on the shape. The slopes, so we're taking a look at the asymptotes here. So after you get your center, okay, you have an r sub y. So r sub y goes up and down so much. Here's r sub y. And then r sub x goes left and right. So if you go up r sub y and you go over this much r sub x, that gives you the rise and the run, the slope of these asymptotes. The asymptotes go through the corners of the rectangle. So there's two slopes, since there's two asymptotes, and we're going to have plus and minus, uphill line, downhill line, r sub y over r sub x. Okay, how do you get the equation of that? Okay, so we're going to use point slope form. Y minus y1 equals m x minus x1. And some people say, well, what's a good point to use? Whenever you're looking at a hyperbola, these asymptotes always pass through the center point. So I'm just going to put a little note down here. The best thing to do is always use the center point. It's a great point to use for both center point of the asymptotes. And it's going to be a nice way to plug in right there the point that you're going to need. R sub f, we need an equation for r sub f, and it's r squared, and we're going to put the major one, and then plus r minor squared. But I guess it doesn't matter where you put them since it's plus. So is this the x or this the y? It doesn't matter, you add them together. Eccentricity is r sub f over, now what's important when you're a hyperbola? I don't care who's major. When you're looking at hyperbolas, I care about who is the transverse. And we'll do some more work with r sub f tomorrow. So for today, what we're going to be doing is taking a look at hyperbolas that are in general form. We're going to put them in a standard form and graph them. Okay, so the first thing I notice here is I don't have equals to 1, and that's what you need to get something in standard form. So I'm going to divide all of the terms by 144, and 9 goes into 144 16 times. So I've got x squared over 16 minus y squared, canceled by 16. Oh, that's going to make a 9. I love when that happens. Doesn't always happen. Equals to 1. All right, so looking at this equation, there's a couple things you should know. The center for this hyperbola is nice and easy, 0, 0. Okay. R sub x, make sure you square root, is going to be a 4. R sub y is going to be a 3. Okay. The slope for these things is going to be r sub y over r sub x. And I'm going to say plus minus here. That's going to be 3 over 4. I am going to switch colors here and get out the pink pen. You have to make sure you take a look at which letter is the positive one. X is first. X is the transverse. Okay, X is the transverse. That's very important because that tells me which way the shape is going to go. So the transverse axis is X, and the conjugate one must be Y. Let's go put all this information on our graph paper. So the center is at 0, 0 right there. R sub x is 4. So we go 4 to the right, 4 to the left. Okay, and what we're doing is we're drawing that rectangle. R sub y is 3. Okay, 3 up, 3 down. Now when you're doing hyperbolas, okay, you got to kind of unthink about ellipses. It doesn't matter who's the big one. What matters with hyperbolas is who's the transverse. Okay, you don't care about major, you care about transverse. After you get your rectangle, you use that to draw your asymptotes. So let's go through the corner, through the center, through the corner. So here's the first asymptote. And then let's draw the downhill asymptote right here. Downhill asymptote. Okay. Now what are we doing with those asymptotes? That helps us draw the shape of the hyperbola the best way. I think I'm going to draw the hyperbola now. The transverse is x, so the hyperbola is going to be going left and right. So you go to the edge of the rectangle, and that is the vertex. I'm just going to put a little v there for vertex. And since the transverse is x, I'm going to approach this asymptote going left and right. Okay, asymptotes are there to approach, get closer, closer. Technically, they don't touch, but they get so close they almost start to write it. So please try to get close to those asymptotes. Okay, so there's your first hyperbola. The vertices, I just put those dots on there. I've got one at 1, 2, 3, 4, comma 0, and one at negative 4, comma 0. And I think I'm going to write that as plus minus 4, comma 0. And the next thing I'm going to do is write the equation of the asymptotes. Okay, so these asymptotes right here, I'm going to do y minus, let's see, the center point is 0, 0. Y minus 0 equals m. Let's do the positive one first, 3/4 x minus 0. This is kind of silly when it's just 0. So I've got y equals 3/4 x and no b value, or b value of 0. Does this look right? Up 3/4. Yes, that's good. And then the other one is going to be negative 3/4 x, because you're going to use the 0, 0 point again. Okay, these asymptotes were really easy because they were on the center. So let's do one where the hyperbola is not on the origin. Okay, this one's going to be a little bit more fun. We're going to have to complete the square and then graph it. So let's go ahead and get all the x terms in a row. The two x terms, x is the positive, so I'll put him first. If y was positive, I'd put him first, but I'm going to do x. And I'm also going to factor out a 9 right away. X squared plus 10x. Okay, I'm going to leave some space. The y's are going to go next, but I am going to factor out a negative 4. Okay, very important that you put a plus or minus there. This is a minus. It's going to be a hyperbola. Y squared minus 8y. And I'm going to go ahead and move that negative 197 there on the right side. Okay, it's half and square time, people. Half of 10 is, squared is, plus 25. Now, is that really 25? 25 times 9 is, good, 225. Try to think about quarters a little bit and figure that out. Let's take a look at the y's. Half of 8, squared is a positive 16. But that's not really positive 16, that's really negative 64. Okay, we're getting there. I'm going to go ahead and do the factoring part now. So we have 9 times the quantity x plus 5 squared minus 4 times the quantity y minus 4 squared equals 2. Oh, go ahead and figure that out for me, please. Help, help, negative. What'd you get? 36. Okay, and now you have to make a 1, so we're going to go ahead and divide all terms by negative 36. Yeah, let's go ahead and do this. Divide all 3 terms by negative. Well, this is weird because a negative divided by negative is going to make positive. Oh man, I thought the transverse was x, but really the y is turning positive. Okay, so let's cancel this here, make a 1 and a 9. Here we'll cancel 9 and get a 4. So what I'm going to do is rearrange this equation, and y, please step to the front. Y minus 4 squared is going to go over 9, and then the negative is going to become the minus sign, and x, you are going to become the conjugate axis. Look at that. Equals 1. When you see a negative on one of the squares, you know hyperbola. But I guess the transverse could always switch. Okay, so who is the transverse? I'm just going to put a star by that guy. The transverse is y. Okay, very important to know that. The center, oh, here's a very tricky thing. The center is change, change. But you have to put the x number first. So when you rearrange hyperbolas and put the x over there, be very careful. The negative 5 has to go in the x spot, and the 4 has to go in the y spot. Be very careful. R sub x is 2. R sub y is 3. The slopes would be plus and minus r sub y over r sub x, 3/2. Okay. The length of the transverse axis, The transverse axis is y. So if it goes up 3 and it goes down 3, that would make it a length of 6. And the conjugate axis is x, so 2 to the right, 2 to the left, that would be 4. Okay, so length you have to double. Very tricky here. You've got a 6, you've got a 3, you've got a 9. Okay, be careful with all those numbers. I'm going to answer all these other questions once I see a picture. So let's go ahead and graph this. The center of the hyperbola is -5, 4. After you put the center dot, what's the next step? Draw the rectangle. So r sub x is 2. Go 2 to the left and 2 to the right. R sub y is 3. 1, 2, 3 up and 3 down. Okay, these numbers don't really tell you anything about which way the hyperbola goes. It's not who's bigger, it's who's the transverse. After you do the rectangle, we're going to draw the asymptotes. So let's go ahead and draw these. There's the first one. And here is the second one. Okay, I think it's hyperbola time. So I'm going to go ahead and get, let's see, the transverse is y. So I'm going to put a vertex right here on the top and the bottom of the rectangle. And I'm going to go ahead and put V for vertex right there. It's going up and down, so let's go ahead and approach the asymptotes. Hyperbola is going up and down. Up and down. After you draw it, I think I'm going to go ahead and state those vertices. So let's see. Looking at the picture, I've got -5, 1. And the other vertice is at -5, 7. Okay, there's the two vertices. And, let's go ahead and write the equation of the asymptotes. Okay, so the equation that I like to use is y minus y1 equals mx minus x1. Okay, and when you're doing this, the slopes that we're going to use are plus and minus 3/2. And the point that I'm going to use is the center, -5, 4. Okay, let's go ahead and label these here. Equation number 1, y minus, give me a y. How about 4? Equals m, 3/2 times x minus 5 is plus 5. Okay, and we'll go ahead and distribute the 3/2. Ooh, this is going to be fun. Y equals 3/2 x plus 15/2 plus 4. So when you bring over the 4, what's that going to be? How many halves? Oh, maybe I'll ask you tomorrow when I see you in class, because you guys are probably trying to do that right now real hard by yourself, right? And the second equation, same setup, y minus 4 equals, the only difference is -3/2 times the quantity x plus 5. So then we'll go ahead and distribute here, and that's -3/2 x, -15/2 plus 4, and that's going to be minus, I can't wait for you to tell me the answer tomorrow. Have a good night.